This is the second video and it's following on from the first video where we started to solve some acceleration problems involving gravity. So I'm now on to example 12 where a particle is projected vertically upwards from a point O with speed u meters per second. So they haven't told us the speed, they've just given it the value u. The greatest height reached by the particle is 62.5 meters above O. Find the value of u and the total time for when the particle is 50 meters or more above O. So if I draw this out, I've got O here at the bottom where my particle starts, and it goes all the way up and then hits the maximum height and comes all the way back down then back to O. And I've kind of drawn it as a bit of a loop. However, we've got to imagine it goes up and down in exactly the same line. That's what we're assuming. However, I couldn't really draw that very well and show all the things that I need to show. So it's projected upwards here with a speed of u, and it gets to a maximum height, so this total maximum height above O is equal to 62.5 meters. And first I'm finding the value of u. So let's start off by writing again what we know. And you can take the positive direction as being upwards or downwards. I think I'm going to choose to take upwards as my positive direction. So if I take positive as upwards, it goes from here all the way up to here, so that is a displacement of 62.5 meters. So what I'm doing, by the way, is I am just looking at going from the bottom to the top. That's the first section that I care about. And u is equal to, well, that's what we're trying to work out, this initial velocity, v. Now at the very top, the velocity will be equal to 0. It's very similar to the question that we did up here, where we said at the maximum point the velocity is 0, because at that point the velocity goes from being upwards, it switches and starts going downwards. So at that instant it is at the top, the velocity is equal to 0 meters per second. And the acceleration is the acceleration due to gravity. Now that is 9.8 meters per second squared downwards, whereas I'm taking positive as upwards, so the acceleration is negative 9.8 meters per second squared. Make sure you're really clear in your head about what we're doing with these sign conventions. If we're taking upwards as positive, then the acceleration is negative because the acceleration acts downwards. Okay, and I am trying to find out what u is. So I'm going to use, if we again had a look at which formula we want to use from up here, I'm going to use v squared equals u squared plus 2as. So v squared equals u squared plus 2as. I want to know what u is, so let's just rearrange. So we get u squared equals v squared minus 2as. And so I know that u is the square root of v squared minus 2as. And then we can just sub in what we know. Well, v squared is 0, so I'm going to ignore that. Then I've got the square root of negative 2 multiplied by negative 9.8, because that's my acceleration, multiplied by, oh, I'm not going to be able to fit this on, 62.5. In the end there. Hopefully as well you can spot that I've got negative 2 and negative 9.8. They're going to multiply to give me a positive, which is good because otherwise I wouldn't be able to square root. So I'm going to then, sorry, let's get back to this one. The square root of negative 2 multiplied by negative 9.8 multiplied by 62.5. And that gives me an answer of u is equal to 35 meters per second. So the velocity at the ball, or whatever we're talking about, the particle, was projected upwards with is 35 meters per second. Now the next part of this question is a really nice part, and it's asking for the total time when the particle is 50 meters or more above O. So the time, let's call this is going to say this is getting a bit messy, let's have a look. We're going to say that from here to here, that is 50 meters. And I want to know the time that the particle spends in this section here. So what I can do is I can look at, well, at what time does the particle go through that point? And at what time does the particle go back through that point? If I know those two times, then I know the difference between them is the amount of time the particle spends above 50 meters. So I'm saying that the displacement, again, I'm going to take upwards as being positive here. The displacement is going to be 50 this time because I care about this point going from the start to this point here. Displacement is 50 meters. The initial velocity, I'm going to use 35 meters per second. We just worked that one out. The final velocity, I don't know. I don't know what the velocity is as it passes those points. The acceleration is negative 9.8, same as before. We're talking about the acceleration due to gravity, but we're taking upwards positive, so that's why we need negative 9.8. And the time is what we're trying to work out. That's what I'm trying to solve for. So if I looked again at which formula I was going to use. I've not got V, I'm not interested in V, but I care about all the other letters, so I'm going to be using this one here, formula 4. S equals ut plus a half at squared. And sub in what I know. Well, S is 50. U is 35. A is negative 9.8, so I've got negative 9.8. Oh, 0.8 over 2 t squared. I'm going to rearrange that because I really don't like having a negative quadratic. I'm going to have 9.8 over 2 t squared minus 35t plus 50 equals 0. And I'm going to use my calculator to solve for t then. So if I solve for t, I'm going to go to, again, the equation function, polynomial of order 2, 9.8 divided by 2, negative 35, oh dear, sorry, just messed up there, plus 50 at the end. And I get that t is either 5.1686, I'm going to keep lots of significant figures in here, or that t is 1.9742. Now, that means that the particle goes up and it hits this point after 1.97 seconds. So it goes up for 1.97 seconds and then it hits that point. Then it continues going up, and after 5.16 seconds, it gets to that point there. So it was here at 1.97 seconds and here at 5.16 seconds. So if I'm looking for the total time that it was above 50 meters, I'm going to do 5.16, take away that 1.97, and that will give me the time that it was in this top section up here. So total time above 50 meters is equal to 5.1686, all that stuff thrown in, take away 1.9742. And again, I'm going to do that on the calculator. Take away 1.9742. And it gives me an answer of 3.19 seconds. And that is the time that the particle is above 50 meters, 3.19 seconds. Okay, and then the final example is example 13, and I love this example. This is a really great example of a hard problem-solving mechanics question. So it says, ball A falls vertically from rest from the top of a tower 63 meters high. So let's imagine, here's my tower 63 meters high, and ball A falls from the top of the tower downwards. I'm going to label this one as well as that's ball A up there. At the same time as A begins to fall, another ball B is projected vertically upwards from the bottom of the tower. So we've got ball B down here is projected upwards with a speed of 21 meters per second. 21 meters per second. The balls collide. So at some point, I'm not sure exactly where, the balls hit each other in the air. Find the distance of the point where the balls collide from the bottom of the tower. So what I'm trying to find is this distance here where the balls collide. Now I'm going to treat both of them separately and you'll see why. What I need to do is I need to work out what the displacement is of A as a function of time. So if I can find the displacement of A as a function of time, and I can find the displacement of B as a function of time, then I know that when those two displacements add to 35, so when B has travelled some distance and A has travelled some distance, and their total distances add to 63, because that's the height of the tower, then that's when they collide. So let's talk first about ball A. So I want to say S is what I'm trying to work out. U is 0, and that's because we said the ball A falls from the top of the tower. It's not been pushed, it's not been shot downwards, it's just falling. So the initial velocity is 0 meters per second. The final velocity we don't know, and we're not really interested in. The acceleration, now I'm taking downwards here as being positive. So the acceleration, which is the acceleration due to gravity, the downwards acceleration, is 9.8 meters per second squared. And I'm taking it as positive because then I know that when S is positive, that's the amount A has moved downwards. T, then, I'm going to say is just equal to the letter T. Okay? I'm just working it out as a function of time. So T is just equal to T. And I want to know what S is. So if we looked again at these, I would say that S, and I'm going to put a little a there just to remind me this is the displacement of A, is equal to ut, so 0t, well I don't need to write that out, plus a half at squared. So plus a half of 9.8, and I'm going to write actually as 4.9, which we know is a half of 9.8, t squared. So at any value of t, the distance, the displacement that A has travelled downwards is 4.9 t squared. Now let's look at ball B. I'm finding the displacement of ball B, that's what I'm trying to work out. Now this time ball B is travelling upwards, so it makes sense for me to take upwards as the positive direction. Because when S is positive for ball B, that is ball B travelled upwards. U is equal to 21. That's because we know that B is travelling upwards 21 meters per second. It was projected upwards with that speed. V we don't know, again, don't really care about. A is the gravity. Now, we're taking upwards as positive, so the acceleration due to gravity is negative 9.8. Again, really important that we've got those signs right in our head. And T, I'm going to say, is just equal to T. So, S is what I'm finding out, and it's the same as one before. I'm still going to use S equals ut plus a half at squared. This time I'm going to say S of B, just to remind me this is the displacement of ball B, equals ut, so 21t, plus a half at squared, so a half of A, negative 4.9 t squared. Okay, so I know that the displacement of A is like this as a function of time. The displacement of B is like this as a function of time. What I want to know then is at what time is the displacement of A plus, the displacement of A plus the displacement of B equal to 63. Because when the displacement of A and the displacement of B add together to make 63, that is the instant, that is the time that those two balls collide there in the air. So I'm going to I want to find when the displacement of A added to the displacement of B equals 63, which is the height of the tower, remember, 63 meters. So displacement A is 4.9 t squared. The displacement of B is 21t minus 4.9 t squared. And I'm saying, when does that equal 63? Well, actually, this is working out really nicely because that 4.9 and this 4.9 are going to cancel each other out. So I just get that 21t is equal to 63. And therefore I can say t is equal to, well, 63 divided by 21, hopefully you can do that in your head, is 3 seconds. So after 3 seconds, that is the point when the two balls collide. So I found the time when the balls collide. However, that's not quite there. We've almost finished the question, but not exactly, because the question's asked for the height from the bottom of the tower. They want to know this distance here. And that is how basically saying, what distance has B travelled? What is the displacement of ball B when the balls hit each other? So I've actually really handily already worked out that equation. So I'm saying when the balls hit each other, the displacement of ball B is equal to 21 times t. Well, we know that t is equal to 3 seconds when the balls hit each other, minus 4.9 t squared. So 3 squared, oh, 3 squared there. So the displacement of B is 21 times 3, minus 4.9 times t squared, 3 squared, which is 18.9 meters. So the distance from the bottom of the tower at the collision, or when the balls collide, might be a better way to put it, is 18.9 meters. So just to recap, to work out the answer to that problem, I first worked out an equation for the displacement of A. I then worked out an equation for the displacement of B. And I said, well, when the displacement of A added to the displacement of B, so the displacement of this one downwards added to the displacement of this one upwards, is equal to 63, the total height of the tower, that must be the point where the balls hit each other. And so I added those two equations together to make it equal 63. I worked out the time at which the collision occurred, and then I used that time to work out the distance here that the collision occurred, so the displacement of B when the collision occurred. That is a really nice example of a hard problem-solving mechanics question. So now that you have done those examples, you should be able to have a go at exercise, I think this is 9E. There are 13 questions to have a go at there.